We've seen integrals like this before, where we have an integral like x squared, which could be differentiated repeatedly until it became 0, and then another function like e to the x, which could be integrated repeatedly until it just stayed e to the x. And these were a great candidate for integration by parts. But if this becomes something like x to the fourth e to the x, or even higher, then we've really got a mess on our hands, because the integration by parts is going to have to be done repeatedly. So the answer to that is something called tabular integration. And with tabular integration, you put your polynomial in the first column with all of its derivatives. So x squared, and then the derivative is 2 to the x, and then 2, and then 0. And then in the right column, you put the other function, whether it be e to the x, or sine x, cosine x, those will also work. So you put e to the x and all of its antiderivatives. So in this case, the only antiderivatives of e to the x are always e to the x. Okay, then we're going to just draw some arrows from the first term in the left-hand column to the second term in the right-hand column, and so on. And then we just put signs in, plus, minus, plus, and the signs alternate. Okay, so then the answer becomes positive x squared e to the x, then minus 2x e to the x, plus 2 e to the x, plus c. And that's your final answer. So the positive sign represents that the first term is positive. This negative sign shows that the next term is negative, and this positive sign shows that the third term is positive. Then the x squared shows up in the first term, the 2x shows up in the second term, and then the 2 shows up in the third term. And of course the e to the x's are the result of what comes out of the right-hand column. It's called tabular integration. Let's give you another example, and then we'll conclude this. Okay, so in the left-hand column, we're going to write the polynomial x cubed and all of its derivatives, 3x squared, 6x, 6, and then 0. And then over in the right-hand column, we'll write sine x and all of its antiderivatives. So sine x minus cosine x minus sine x, and then cosine x, and back to sine x. Then we draw our arrows. First arrow is always positive, next arrow is negative, next arrow is positive, next arrow is negative. Now we're just going to write out our answers, taking the first term from the left column, x cubed times negative cosine x is going to make my first term negative. And then I'm going to subtract negative 3x squared sine x, so that will end up being positive, plus 6x cosine x, and then minus 6 sine x plus c. So the final answer is going to be negative x cubed cos x plus 3x squared sine x plus 6x cos x minus 6 sine x. And that's tabular integration. Use it whenever you see a polynomial and a second function whose integral is not going to get any worse as we move through integration by parts. Okay, thanks for watching.